Okay, welcome to video number 14 of chapter 2 series. Now in this video we are going to continue the examples. So next example is from exercise example number 2.13. Question is like this: the partial pressure of ethane over solution containing 6.56 into 10 raised to minus 3 grams of ethane is 1 bar. If solution contains 5.5 into 10 raised to minus 2 grams of ethane, what is the partial pressure of the gas? Now here in the question, two weight of ethane is given, so I am taking two conditions here, condition number 1 and condition number 2. Now in first condition, 6.56 into 10 raised to minus 3 grams of ethane is dissolved in some amount of solvent. Here as solvent I am taking water, and here I have written mass of ethane 6.56 into 10 raised to minus 3 grams. At that time in the question is given to you ethane is 1 bar, pressure is at 1 bar at that time in that condition, so pressure is 1 bar. Now in condition number 2, mass of ethane is 5 into 10 raised to minus 2 gram. Pressure we want to find out in that condition. For that, Henry's constant Kh value is not given to us. So what we are going to do first, what was the Henry's law? P is equal to Kh into X. For first condition we have P. Kh we want to find out, mole fraction we are going to find out, and from this equation we are going to find out first Kh value, then use this Kh value for second condition. Okay, so here I have written for first condition P is equal to Kh into X. Now assume that in both condition mass of solvent, here I have taken solvent H2O, mass of solvent is 1000 gram. So moles is equal to 1000 divided by 18 is equal to 55.55 moles. Okay, this you have to assume. Now moles of ethane for first condition, we want to find out mole fraction. For that we have to find out moles of both component. Moles of water we find out for 55.55. Now moles of ethane is equal to mass of ethane divided by molecular mass. Formula for ethane is C2H6. Carbon is 12 atomic mass, carbon 1 atomic mass. From the formula C2H6 you will derive molecular mass 30. Okay, so 6.56 into 10 raised to minus, that is weight of ethane divided by molecular mass 30. You will get 0.2186 into 10 raised to minus 3. Now mole fraction of ethane. What is mole fraction? Formula moles of ethane divided by total moles. So here I have written moles of ethane 0.2186 into 10 raised to minus 3 divided by 0.2186 into 10 raised to minus 3 plus 55.55. Now compare these two values. This value 0.2186 into 10 raised to minus 3 is very less than 55.55. So I am neglecting this value. Okay, I am neglecting this value. So what you will get, 0.2186 into 10 raised to minus 3 divided by 55.55. By this division you will get the value 0.003936 into 10 raised to minus 3. So we get mole fraction here. Now this was the Henry's law. P is equal to Kh into X. P, that is 1 bar, that is given in the question. Kh we want to find out. Mole fraction we derived 0.003936 into 10 raised to minus 3. So what is KH? KH is equal to 1 divided by આખી ટર્મ છે ડિવિઝનમાં થશે 1 divided by 0.003936 into 10 to minus 3. You will get 0.2540 bar. That is KH value. Okay. Now for second condition, same formula we will use. For second condition, we want to find out pressure. KH value we derived, and X value, mole fraction value, we are going to find out. So for second condition also, suppose the mass of water is 1000 gram. So moles of water will be 55.55 and moles of ethane, that is equal to mass of ethane divided by molecular mass. For second condition, mass is given to 5 into 10 raised to minus 2. So here I have written 5 into 10 raised to minus 2 divided by 30. You will get 0.1666 into 10 raised to minus 2 moles. So what is mole fraction of ethane? Mole fraction of ethane is equal to 0.1666 into 10 raised to minus 2 divided by 0.1666 into 10 raised to minus 2 plus 55.55. Okay. Now here also I am neglecting this term. So what we have here, 0.1666 into 10 raised to minus 2 divided by 55.55 is equal to 0.00300 into 10 raised to minus 2. This is mole fraction. Now put this value in main equation. 0.2540, that is KH value we derived that. X mole fraction we derived that 0.00300 in 300 into 10 raised to minus 2. By multiplication of these two, you will get 0.007626 into 10 raised to minus 2 bar. Okay. So what we did, first for two condition we have two values here. For first condition we derived KH value, then that KH value we used in for second condition. Okay, that is the main method. So these were the examples based on Henry's law. Now next theory was Raoult's law. In Raoult's law you have two types of Raoult's law. Raoult's law for volatile solvent plus non-volatile solute, and for both volatile. Two different laws were there. Okay, Raoult's law for volatile solvent and non-volatile solute, and second condition was both volatile. If both are volatile, then a different equation was there. So before continuing these examples, please do remember that two equations. Repeat that two theories once, then after continue these examples. Okay, hope you have repeated that two theories. Now according to that, we have few examples based on that two theories. First, Intext question number 2.8. First read the question. The vapor pressure of pure liquid A and B, two liquids are here. The vapor pressure of your pure water is important. Pure liquid A and B are 450 and 700 mmHg. At 350 find out at 350 Kelvin temperature. Okay, find out composition of liquid if total vapor pressure is 600 mmHg. Also find out composition in vapor phase. Okay, that is the question. First, try to understand the question first. So we have two liquids here, liquid A and B. When they are in pure form, they have vapor pressure 450 and 700 mmHg. So these are values of P10, P20, 0. ઓકે, એ બંનેની વેલ્યુ આપેલી છે. નાઉ સપોઝ આઈ હેવ મિક્સચર ઓફ ધીસ ટુ. મિક્સ કર્યું એ વખતે, બંનેનું મિક્સર કર્યું એ વખતે પ્રેશર ચેન્જ થાય છે, વેપર પ્રેશર ચેન્જ થાય છે. સો ટોટલ વેપર પ્રેશર વેન ધીસ બોથ આર મિક્સ્ડ, then total vapor pressure is 600 mmHg. So here I have written P total is equal to 600. Okay, now what do we have find out here? We are going to find out the composition of A and B in liquid form. જે liquid form માં છે એમાં કેટલો A છે અને કેટલો B છે એ find out કરવાનું છે, plus composition in vapor phase also we are going to find out. જે ઉપર વેપર કલેક્ટ થશે એમાં બી એ અને બી હશે, સો એની અંદર કેટલો એ હશે અને કેટલો બી હશે. વી આર ગોઈંગ ટુ ફાઇન્ડ આઉટ ધેટ ઓલ્સો. સો હિયર વી આર ગોઈંગ ટુ ફાઇન્ડ આઉટ ટોટલ 4 વેલ્યુઝ. Composition of component A, component B in liquid form, and in vapor form component A and component B. Okay, so here both are liquid, બંને liquid છે, so both are volatile. So we are going to use Raoult's law for volatile solute and volatile solvent. What was the equation? Equation was like this: P total is equal to P10 x1 plus P20 x2. Now instead of this x2 I am putting 1 minus x1. So P10 x1 plus by multiplying P20 in this bracket, P20 minus P20 x1. Now from first and last term I am taking common x1. So I will get P10 minus P20 x1 plus P20. If you remember this equation, you can write down direct this equation. Okay, that is not a problem. તો તમને યાદ રહેતું હોય તો ડાયરેક્ટ આ ઇક્વેશન લખી શકાય. I don't remember, that's why I have this method. Now here we have these 3 values. P total we have, P10 we have, P20 we have. This x1 we want to find out. So I am putting the values here. P total, that is 600, P10 that is 450, P20 700, x1 we want to find out, plus P20 700. So you will get 600 is equal to 450 minus 700 minus 250 x1 plus 700. Now this 700 will go on other side, so it will become minus 600 minus 700 is equal to minus 250 x1. So you will get minus 100 is equal to minus 250 x1. Both are minus, so I have make them positive here. Now from that you can find out x1 is equal to 100 divided by 250. You will get value 0.40. 100 divided by 250, 0.40. Now what is x2? x2 is equal to 1 minus x1. x1 value we find out 0.40, so x2 will be 0.60. Now these both value x1 and x2, that are composition in liquid form. Okay, so 2 values we derived. Now remaining 2 values we are going to find out. For that, this is the Raoult's law. P1 is equal to P10 x1, P2 is equal to P20 x2. Now P10 value we have, x1 value we have, P20 value we have, x2 value we have. So by putting these 4 values we are getting P1 is equal to 180, P2 is equal to 420. Now this formula you don't have in theory. Okay, theory માં આ formula નથી, direct examples માં જ આપેલી છે formula. So x1 mole fraction of solvent in vapor phase is equal to P1 divided by P1 plus P2 is equal to 180 divided by 180 plus 420 is equal to 0.30. and x2 we want to find out. X2 is equal to what? 1 minus 0.30, that is 0.7. Okay, this is the formula that you have to remember because it is not in your theory portion. Theory માં નથી આ. What is the formula? The formula is to find out the composition in vapor phase. Vapor phase ની અંદર composition find out કરવા માટેની formula છે x1, that is mole fraction of solvent is equal to P1 divided by P1 plus P2. Okay, એ formula યાદ રાખવાની છે. So we derive all four values now. Now the next example, that is Intext question number 2.9. First read the question. Vapor pressure of pure water at 298 Kelvin is 23.8 mmHg. 50 gram of urea is dissolved in 850 gram of water. Calculate vapor pressure of water for this solution and its relative lowering. Now here we have solution of water and urea. Water is in liquid form, urea is in solid form. So what is the mixture here? Volatile solvent plus non-volatile solid. Urea solid છે, so it is non-volatile. So here we are going to use for another formula of Raoult's law. What is the values that is given to you? First value, that is here vapor pressure of pure water. Again pure word is there, so it is for water, so it is for solvent. So P10 is equal to 23.8 mmHg. Okay, mass of water that is given to you 850 grams. So mass of water is equal to 850 grams. So I can derive moles of water here. Moles of water is equal to 850 divided by 18 is equal to 47.22 moles. Mass of urea is given to you 50 grams of urea. So mass of urea is equal to 50 grams. Moles of urea is equal to 50 divided by 60. Urea ने formula होती NH2CO NH2. Nitrogen is 14, hydrogen 1, carbon 12, oxygen 16. These are the atomic mass. From that you can derive the molecular mass. Molecular mass you will derive 60 gram per mole. So moles of urea is equal to 50 divided by 60 is equal to 0.833. Now mole fraction of urea. Mole fraction of urea is equal to moles of urea divided by total moles. 0.833 divided by 47.22 plus 0.833. Now here I am not neglecting this value. Okay, when to neglect that value? I am telling you, this is very important point. If this value moles of solute, this value, what is this value? Moles of solute is less than 0.5, then you can neglect it. Okay, less than 0.5 you can neglect it, but it is greater than 0.5, then you have to consider that value. Again, if moles of solute is less than 0.5, you can neglect it, otherwise you have to consider that value. So it is greater than 0.5, so I am considering that value. So 0.833 divided by this total, you will get 48.33. So by dividing these two, you will get 0.01723, that is mole fraction of urea. Now the formula for Raoult's law was like this: P0 minus P divided by P0 is equal to X2. X2, that is mole fraction of urea. P0 value we have 23.8, P we want to find out, P0 again 23.8 is equal to mole fraction we find out 0.01723. Now by solving this equation you will get P is equal to 23.38 mmHg. Okay. Now example number 2.15 from your exercise. It is from your exercise now. What is the question? An aqueous solution 2% concentration આપેલો છે 2%. Non-volatile solute exert a pressure of 1.004 bar at normal boiling point. Solvent, normal boiling point of solvent. What is the molecular mass of solute? Again, now understand the question. What is the question? A solution is there that is non-volatile plus volatile. Okay, and concentration is 2%. Now 2% weight by weight. I told you if nothing is given to you, weight by weight છે, weight by volume છે, એવું કંઈ આપ્યું ના હોય, then consider it weight by weight, and the pressure of that solution is given to you 1.004 bar. 1.004 bar એની કઈ વેલ્યુ આપી છે? when it is solution. Now for pure water pressure is 1.013 bar. Again, this value you won't get it in exam. Remember this value. Pressure for pure water is 1.013 bar. So P10 we are going to take P10 is equal to 1.013 bar. Okay. So what is it? What are the values we have here? 2% weight by weight. P, that is pressure for solution 1.004 bar. P10 pressure for pure water 1.013 bar. Now concentration is given to you 2%. So what is this 2%? Means 2 grams of solute plus 98 grams of solvent. Solvent is given to aqueous solution. That is the question. So aqueous solution is in water. So mass of solute is equal to 2 grams. I am denoting that by W2. Mass of solvent, that is 98 grams. I am denoting that by W1. Molecular mass of solvent means water no molecular mass 18. So molecular mass 1, that is 18. Now it is given in the question that solution at normal boiling point. So here P10 would be standard pressure 1 atmosphere is equal to 1.013 bar. I told you this value you have to remember. Now what was the equation? P10 minus P1 divided by P10 is equal to X2. X2, that is mole fraction of solute. Now mole fraction is formula so the N2 divided by N1 plus N2 by, and I am neglecting N2 from denominator. Okay, again નીચેથી N2 में neglect કરી દીધા direct. So here I have written N1 only. So N2 ની formula moles of solute W2 by M2, N1 ની formula W1 by M1. So P10 you have 1.013, P1 you have 1.004, P10 1.013, W2 that is given to you 2, M1 18, M2 you want to find out, and W1 98 grams. Now this subtraction you will get 0.009 divided by 1.013 is equal to 2 into 18 divided by M2 into 98. Now this value, if I rearrange, this value will go upward side, this value will go downward, and this 1.013 will go on upper side. So M2 is equal to 2 into 18 into 1.013 divided by 0.009 into 98. By solving this, you will get value 41.34 gram per mole. That is your answer, molecular mass of solute. Okay, so that's it for today. Homework examples you will get in the description. Thank you.